Hello and welcome. We are going to learn about Hugging Face transformers and how this tool is used for NLP applications. Before moving forward, we are going to discuss about introduction to Hugging Face, what are transformers, key features of Hugging Face transformers, Hugging Face practical applications, Hugging Face NLP model timeline, setting up Hugging Face transformers, fine-tuning models with transformers. Then we're gonna discuss about the future of transformers. Introduction to Hugging Face. Hugging Face was founded in the year of 2016 by Clement, Julian, and Thomas. Initially, the company started as a chatbot developer, but soon pivoted to become a central hub for AI research and machine learning development. Hugging Face mission is to make cutting-edge machine learning accessible to everyone. It is now an open source platform that hosts thousands of state of the art models across various domains with a strong emphasis on NLP. We discussed about Hugging Face. So, what are transformers? Transformers were introduced in the landmark paper in 2017, which is called Attention is All You Need, by Google researchers. This architecture revolutionized NLP by overcoming key limitations of previous models like recurrent neural networks. Then, what are key architectural components of transformers, which includes self-attention mechanism, allows models to weigh the importance of different parts of input data, enables more contextual understanding, which is nothing but it helps the model focus on the most relevant parts of input data. Then, about parallel processing. Unlike recurrent neural networks, transformers process entire sequences at once, which include improving efficiency. Positional encoding. It allows the model to understand order and relationships of tokens. These features enable transformers to handle long-range dependencies, complex language tasks, and multi-domain applications more efficiently than traditional models. We discussed about transformers and what are they. So let's look at transformers in action. Tra- Transformers have significantly improved AI performance across multiple fields. These key advantages include improved performance on complex language tasks, which are better handling of long-range dependencies, more efficient training and inference, adaptable to multiple domains beyond text. Applications. Let's look at the applications of transformers, which include natural language processing, includes text generation, translation, summarization, sentiment analysis, and question answering. Then, for computer vision, it has vision transformers, which are used for image classification tasks, multimodal tasks, models that handle both text and image data such as CLIP and DAL-E. We studied about transformers, Hugging Face, and the action of transformers. Let's look at the key features of Hugging Face Transformers library. It contains over 100,000 pre-trained models from leading researchers, ready to use for tasks like sentiment analysis, text summarization, and many more. Hugging Face has easy to use API, which means it has simple integration in Python with their package name called transformers. It has ready available state of the art models like BERT, GP2, Robota, T5, BART, etc. Models trained on vast amount of data. We're going to discuss about these models later in the slides. Let's look at Model Hub, comprehensive library of pre-trained models. These models include natural language processing, computer vision, audio processing, and multiple support. These all models are available and ready to use in Hugging Face Transformers library. Let's look at the Hugging Face practical applications. These applications include for natural language processing, which are text classification, named entity recognition, question answering, sentiment analysis, machine translation. Beyond NLP, it also has models for image classification, object detection, audio transcription, code generation, multimodal AI tasks. The real world use cases or applications include customer support chatbots, content recommendation systems, medical research analysis, legal document processing, and code automation tools. Let's look at the Hugging Face NLP model timeline. The image contains all the transformers which are included right now in the Hugging Face library, transformers library, which are some are encoder transformers, some are decoder transformers, and some transformers works as both encoder and decoder. Let's learn them in detail. Hugging Face has continuously expanded its model offerings. Let's talk about encoders first. BERT, which is BERT, is an encoder only transformer that randomly masks certain tokens in the input to avoid seeing other tokens, which would allow it to cheat. The pre-trained objective is to predict the masked tokens based on the context. This allows BRT to fully use the left and right context to help it learn deeper and richer representation of the inputs. Robota. Robota improved upon this by introducing a new pre-training recipe that includes training for longer and on larger batches, randomly masking tokens at each epoch instead of just once during pre-processing, and removing the next sentence prediction objective. But training large models is computationally expensive. One way to reduce computational costs is using a smaller model like DistilBERT. DistilBERT uses knowledge distillation, a compression technique to create a smaller version of BERT which keeps nearly all of its language understanding capabilities. Albert reduces memory consumption by lowering the number of parameters in two ways, separating the larger vocabulary embedding into two smaller matrices and allowing layers to share parameters. Debut added a disentangled attention mechanism when the word and its position are separately encoded in two vectors. This is all about the encoder transformers. Then let's discuss about decoder transformers. GPT-2 is a decoder only transformer that predicts the next word in the sequence. It masks tokens to the right so the model cannot cheat by looking ahead. By pre-training on the massive body of the text, GPT-2 becomes really good at generating text, even if the text is only sometimes accurate or true. ExcelNet combines the best of both BRT and GPT-2 pre-training objectives by using a permutation language modeling objective that allows it to learn bidirectionally. Then next it's about GPT-J is LLM with 6 billion parameters and trained on 400 billion tokens. GPT-J was followed by OPT, a family of decoder-only models, the largest of which is 175 billion and trained on 180 billion tokens. Bloom was released around the same time and the largest model in the family has 160 176 billion parameters and is trained on 366 billion tokens in 46 languages and 13 programming languages. This is all about the decoder only transformers. Let's decode about encoder decoder transformers. But BART keeps the original transformer architecture, but it modifies the pre-training objective with text infilling corruption, where some text spans are replaced with single mask token. The decoder predicts the uncorrupted tokens, future tokens are masked, and uses the encoder's hidden state to help it. Pegasus is similar to BAT, but Pegasus masks entire sentences instead of text spans. In addition to masked language modeling, Pegasus is pre-trained by gap sentence generation, which is GST. The GST objective mask whole sentences important to a document. Replacing them with a mask token, the decoder must generate the output from the remaining sentences. T5 is more unique model that casts all natural language processing tasks into a text-to-text problem using specific prefixes. This is all about the transformers which are currently available in Hugging Face transformers library. So let's move forward. As we discussed like everything about the what are transformers, what is Hugging Face, and what are the all the available models in the Hugging Face transformers library. Let's look at how we can set up Hugging Face transformers. So first we have to install the library. To install the library we use pip command, which is Python package installer. So for this the command is pip install transformers. So we can also install additional libraries for specialized tasks, like for deep learning models and other models we use Torch or TensorFlow. So for CPU only version transformers, to install those CPU only version transformers we use command pip install and the name of the library we want to install. Let's look at pre-trained models. So how like we already installed the transformers package. So how do we use the package to load the model which has already existing pre-trained models? So for these we have to import pipeline which is available in transformers. Into the pipeline we have to specify which model, like which operation we are trying to do. So for this example, we used sentiment analysis. So for sentiment analysis, we created a pipeline using transformers library. So for this, we have passed the text as some text like I love using Hugging Face as a input to the sentiment analysis model in the transformers. So the output is positive. It says it has label as positive and with a score of 99.9%. So let's move forward. Like after, so how do we work to pre-train models? So for pipeline API, simplified interface for tasks like text classification, token classification, and question answering. It supports tasks like sentiment analysis, text generation, translation, etc. As in the previous slide, we discussed about sentiment analysis. Let's look at the example for text generation using GPT-2. So similarly, we have to import pipeline from transformers library. So for this, instead of using sentiment analysis, we need to specify text generation as we are working for text generation here. So we need to select which model we want to use. So for this example, we used GPT-2. So for this, we have to give an input some sentence for which we need to generate a text. So we can specify max length as 50, like any other value. So how much length we want the text generation should be. So the output of this program will be the text generated for the given sentence, like it's for example in this example it is once upon a time. So it will generate based on the given prompt the text for the given length of the. So this is how we import and use pre-trained models using Hugging Face transformers library. Then let's move forward and discuss about fine-tuning models using Hugging Face library. So why we have to fine-tune? So while pre-trained models work well out of the box, fine-tuning help improve accuracy on custom datasets. Fine-tuning is helpful for customizing models for specific domains, which is, for example, it is legal, medical, financial documents, achieving better performance on specialized datasets. Hugging Face provides the trainer class. for easy fine tuning. This allows researchers to adapt models to their unique needs while leveraging powerful pre-trained architectures. Demonstration of fine tuning on the text classification task with custom data. What are the what is the future of transformers? The future of transformers is rapidly evolving. So it's the as we see the emerging trends. So first one is increasingly large models. So it's nothing but more powerful language models are being developed. Improved efficiency. Research focuses on making models faster and less resource intensive. Multimodal AI, combining text, image, and audio data for richer AI applications. Ethical AI development, addressing biases and interpretability challenges. More specialized domain models. And what are the challenges and opportunities for transformers? It includes computational requirements, bias mitigation, interpretability, democratizing AI access, but ongoing research is addressing these issues. Coming to the conclusion. So, in this presentation, the key takeaways are transformers have revolutionized AI. Hugging Face makes advanced models accessible. Continuous innovation drives the field forward. And we can see the resources to further learn about this Hugging Face transformers. There is a documentation for the Hugging Face transformers, and it has GitHub repositories, online courses, and tutorials. Quick recap on the presentation what we did right now. So, Hugging Face transformers provide easy access to state of the art models for NLP, computer vision, and beyond. Powerful features for fine tuning, deployment, and research. Thank you.